Okay, welcome back. It is the day 6 of building the Oasis, and let's get right to it. Yesterday, we created a ton of documentation around how we want to build out the world that we are working in. And on day 2, I believe it was, we had tried to do this before, and it didn't really work out. And I'm very curious because yesterday we put it a ton of requirements that I think is a little bit ambitious, but yeah, we'll see how it went. If we get back to our development screen and just have a look here, we'll see that the UI actually ended up crashing. So some weird stuff has been going on, and it doesn't look too good. That's something that I need to fix in the OneUp code base. Anyway, if we go to the MCP server and have a look here, we can see that all of the items here have ticked green, and we can go to the tree and see all of the things that we had to do. There are quite a lot of different things. We had 138 tasks, 36 test cases, and so on and so forth. If we click on the product, we go to the to-dos, we'll see that they have all been stroked out as being done. So the real question is, what has been done? Is it any useful at all? And how much closer are we to getting the Oasis up running? Let's try to do cargo run. Actually, before we do that, let's just have a look at what's in here. So you'll see that there is a README file, and we just do cat README. And in here, oh wait, let me just redo that one. In here, if we go to the top, you'll see that it writes out what features were implemented. And so for the bigger part, this has just been standing by itself. I've been answering approve every now and then, and answered a few other questions. But other than that, it has been almost autonomous. So it claims here that the move is in place and that we have a lot of different things that ought to be working, including such things as inventory, pickup objects, and whatnot. We'll see. Other than that, it has a description of all the things that's supposed to work. So let's try to run it at this point. Let's see. Okay. Okay, so we see it starts up and no issues. Let me pull the screen over here so you can see. This is what it looks like. Not exactly what I had in mind, but we do see that we have the nicely auto-generated landscape in the background. Now the question is, will this perform? Okay, so we can move sideways, we can move back and forth, we can look around. Okay. Oh, this is a bit hard to control. Okay, so the landscape actually looks kind of okay. This is very Minecrafty, but we have this completely auto-generated landscape. It feels a lot more like a world than the first thing we did. That's not too bad. Oh. Shoot, there. Let's try to go back to see if we can do anything with these E. Oh, whoa. Oh, nice. How cool is that? I can throw at things. Okay, this is a lot more interesting than the first thing we did. Right, let's see what else we can do. Physics, can we jump and stuff? So one of the requirements was that we wanted to have physics as well. And it's created a stairs here, so let's check that out. Oh, yay. It seems that I can jump. Wait, I can't see anything. I'm completely lost. I think that the controls could use a little bit of help. So you see, solid objects do block my way and I can jump onto them. So that's super cool. Oh, and I fell down. Okay, but that works. That was kind of nice. Oh, locked requires a key. Okay. Oh, nice. So we can actually interact with objects as well. So this allows us to open and close doors. Nice. Oh, and the ball is rolling. Cool. I don't think anything happened. Let's say that I picked up some coin. Okay. That didn't seem to work. Oh, we can climb that one. Wait, how does that work? Oh, nice. We also have the climbing ability. Oh, that red ball disappeared. Did you see that? I wonder, let's just jump back here. We had a set of controls up here. So we should be able to talk to NPCs. We should be able to pick up, interact with things. We can definitely interact with things. We can orbit, we can jump. And what else do we have here? Climb, we confirmed that one as well. Oh, inventory. We haven't tried that. Let's try that. Oh, nice. We picked up 2 of those and 2 of those. Try to drop. Oh, nothing happens when we try to drop it or use. And how do I exit this one again? Ah, tap. Okay. Okay, but this is actually a whole lot better than what I'd hoped for. This looks like a man. Hey, we can talk. Oh, nice. It just removed me from the screen. Hilarious. Oh, so we got some supplies. Okay. Well, this is actually not too bad. Nothing happens here. Oh, something does happen. Oh, so I can hold on to it like that. How cool is that? Nice. Wow, this is actually... Oh, that was not what I wanted. I wanted to pick that one up again. Hey, stop. Okay. Anyway, this is a pretty good start, I think. I mean, we have inventory, we have basic physics going on. Well, actually, we haven't really tried the physics all that much. What happens if I jump off here? Oh, we threw one of the boxes down there and that one was there all along. It's gonna... Oh, we can jump. Nice. I don't think we get back up there. That's pretty cool. So this is very Minecrafty in the layout, but Honestly, this is really good for we spent 40 minutes yesterday creating all the requirements, all the documents around this, and we're now at a point where we can do basic things like jumping. We can walk around. We have we have inventory. We have a whole bunch of other things. So this worked a lot better. And I think one of the reasons is that the A server has become a lot better over the past week, but also we gave it examples of what the code could look like. And so it's very clear that it's taking a lot of inspiration from those things and is using it. So I think this goes to show a really important thing. People say that boilerplate code is dead. I don't think so. I think that you need boilerplate code in order to get your AI to be where you want to be a lot faster. Have something that you consider good quality that it can learn from and take from. So if you have a component library of the things you want to do, then that can really accelerate things. So you can just copy it across, make adapt it to your specific needs, and then use that for deployment. I think that's really key. I think one of the things we probably want to do now is take the code and just have a look at how it's structured. My guess is that it will be a relatively big one crate code, and we want to divide that into several crates. We also want it to divide the client from the servers. Right now, I am pretty sure, let's check, but I'm pretty sure that client and server will be one and the same thing. Oh, nice. It also implemented the zones, it looks like. Anyway, let's have a look here. So if we do saves, oh, that's actually not what we want. Let's see. And yeah, so it's all in script. We probably want to have this divided into minor crates, right? So we'll have a world crate and UI crate and all of these things. But then we also need to have a networking and we need to have a client. So I think this will be our next challenge to try to do this. So let's see if we can set up some of the requirements already now and then just get this running overnight so we can have the next version of it tomorrow. And then once we get that up running, we can start thinking about how we will split the networking. Sorry, basically take the servers and make them divisible in these zones. I do have some ideas on that. We'll see how exactly we'll do that, but the first step must be to divide this up if this is to work. So let's get back here, and we probably want to quit this one first and then just start it again. Okay. Okay, so I'm going to put in there that I don't want any file that's bigger than 1500 lines. And even 1500 lines is probably too big, so we probably want it to be more like 1000 lines. And so the reason for this is that one, that, oh, I lost my thread there, sorry. So the reason for this is that, first of all, 500 lines of code amounts to a lot of time to roughly 10,000 tokens. So 20,000 tokens seems to be the absolute max that we should ever have in a file. The second reason is that it's really not very maintainable to have these ginormous files with all the code in. And 1,000 lines. Oh. And this seems like a really good next step, right? Because what we really want here is we want it such that we can connect multiple people. If we can't achieve that, we're never going to get the Oasis. And the other things will help us get maintainability of the project. Let's do that. Could you carefully study code and sleep work, then to use the base framework, define the to that. That should be a question mark, shouldn't it? Cool. Let's see what happens now. Hopefully it will study the code for a little bit. Okay, so while we are waiting for it to do this, I hope you notice how much the structure we're putting in here actually helps guide the process of where we want to be. The fact that we are having small tasks that are easily linkable to other tasks makes it's very, very easy for the LLM to get an understanding of what we're trying to do. And at least I was pretty surprised how well this worked for what we have done here. And I'm very curious whether we can scale it. At the same time, I'm actually planning of making a new version of the ACE framework where things are put into a database instead to make sure that we have semantic similarity as well, and be able to have more advanced relations. So one of the points we're trying to do here is to make it so that whenever we want to construct a specific context, that we can easily fetch those bits and create that context such that it becomes a huge memory for the LLM or for the agent. Once that has been done, my next plan is to take that and build that into a pro version of OneUp code that I'm building out, where we'll have more structured WASM-based agents. And these WASM-based agents will have specific workflows that it can adhere to. And this will hopefully make this ACE framework a lot more robust, in particular in the testing and the formal requirements. So what I found is a lot of times the LLMs just jump right into coding it. It doesn't care about understanding the problem, and it doesn't care about many things. So if we can guide it, and we're already doing that with the ACE framework, but if we can guide it to do that consistently and in a structured way, so this always happens, we are in a way better position than everybody else in this space. And so that's really the goal here. And in the meantime, we'll be using this project to figure out how well these things are working. And so far, I'm pretty happy with what I'm seeing, right? So we did the journalist, and we could probably integrate that into our system here. So you saw we had this person inside of the game. Now we could take the journalist concept and then just move that right into the person. That really ought to be a very, very simple thing to do. At least in my head it is. And the LM has all the code, so this should be just a matter of doing it. Let's see here. Are we getting any new tasks or anything else? We do have 2 more tasks now, and I need to work out a better UI for this because I can't actually see what they are. Let's try to have a look here. If we go to the product, maybe they're under there somewhere. Oh yeah, here. New epic. Let's see what that one says. Architecture refactoring, create, blah, blah, blah. This is perfect. Oh, nice. So it's now mapping out all of the structure that it thinks we should have. Oh yeah, Lua scripting. I completely forgot about that. So if you remember yesterday, we actually asked for Lua scripting, and you can see here that, all right, you can see here that it actually has that in mind now, that it needs to remember that. Cool. And it has our requirement, no more than 1,000 lines. Okay, let's see, 140 tasks, 146 tasks. So this is just going to follow the normal process now that we've been using the other times. So basically, plan out the project in a ton of detail before we start doing anything. Okay, what does it say here? Start this feature. What does that? I ought to know that, but I don't. I think it means asking a lot of questions. Yeah, it does. Something like that. Drawing information from somebody. Let's just do one. Other actors. Who are the primary users of the create structure? Thinking developers, game developers. Yes. Developers. So this is actually one of the processes I'm really happy about, because the fact that it asks me about all of these questions all the time makes that a lot of times we get things a lot more clear from the get-go. What specific types and components from the current code base should go into put them all into core for now. Them into core for now. Well, actually, So I'm thinking we probably want to have an Oasis config crate to deal with the configuration of the system. Put the rest into core. This should. Yes. Um, Oasis. Make a crate folder, a workspace file. Keep the experiments folder, but exclude that from the workspace. That seems sensible to me. Should there be a shared version of the... Yes, please use shared versions. This is what API should it expose? I'm thinking patterns like components derived from macros, more common traits like reflect for Bevy inspector. I'm a bit on thin ice here. These are a lot of questions. I've never really used Bevy before. I think we probably yes. D6. Let's just expose the things we believe that other parts of the system will use and make it such that we can easily extend it. Acceptance criteria for this feature is being done. I'm thinking workspace compiles with built from root core, all existing tests pass, simple example with a test binary. Yes, that sounds good. Sounds. Again, one of the really key things here is that we get acceptance criteria for everything we are doing, right? And That the purpose of that is that we want to be able to evaluate the changes that was made to the code base against what the acceptance criteria are. And later on, when we get better at all of this, we want to be able to evaluate the acceptance criteria against whatever we observe in the system. I still need to figure out how we're actually going to do that, whether that would be through recording the screen or something different. Um, that's unclear, but hopefully we'll get to a point where we actually can solve that in a nice way. Hmm. If the config file is missing, create a new default config. Seems sensible. Otherwise, it's going to be a pain to start the program. Okay, and we're back to the normal case of creating more tasks, creating more test cases, and all of these things. So I think that is really great. At this point, I'm just going to leave it to do its job. And then once it's done with that, I'll ask it to start doing the implementation. Hopefully, when we come back tomorrow, we will have a server, we will have a client, and we will have a nice structure of the files. And that's pretty much it for today's live stream. So I hope you enjoyed it, and I'm really curious to see where we will be going with all of this, but I'm actually super impressed with what we have managed to do in a fairly short amount of time. So if you just think about it, we have a full world now. Like, obviously the things are not looking great, but you can move around. You have physics that feels realistic. You have the possibility of interacting with the objects. You have the possibility of generating landscapes. And on top of that, we spent 40 minutes creating the requirements for this, and then it just went off and it did all of this. This is so much better than what we did the first time. And on top of that, we already did the journalist thing where you get to talk to an LLM directly, and it waits for its turn to answer to what you're saying. So we could integrate that into the game. And I think this is going to be so much fun to play around with. I think there's a ton of learning for us here. All right. Thank you so much for watching, and see you again tomorrow.